This is part 2 of the video that covers the review sheet for test number 4 in AP Calculus AB, covering position, velocity, acceleration, implicit differentiation, and related rates. So here we're looking at implicit differentiation. They're asking us to find dy over dx if x squared minus 3y squared equals 4xy. We're taking the derivative with respect to x, so that means the derivative of x squared is simply 2x. We don't need to put anything like dx over dx because that just cancels out. Okay, the derivative of 3y squared would be negative 6y dy over dx. Now for the 4xy on the other side, we're going to need to do the product rule. So I'll do this down, we'll do this over here for now. F will be 4x, g will be y, f prime is simply 4, g prime is dy over dx. We get f prime times g, which is 4y, plus f times g prime, that's 4x, dy over dx. That's step 1 for implicit differentiation. You have to take the derivative with respect to x, which we've now done. The next step is to separate the pieces that have dy dx from the pieces that do not. So I'm going to subtract the 4y over here and add the 6y dy dx over here, giving me 2x minus 4y equals 4x dy over dx plus 6y dy over dx, and then factor out the dy dx, and finally divide over. So the 4 steps involved here are to take the derivative with respect to x, separate those with dy dx from those that don't have dy dx, factor out the dy dx, and divide. Now if you notice, all 4 of these pieces have a 2 in common, so I'm going to cancel those out and get x minus 2y over 2x plus 3y. Okay, number 12, find dy dx if sine of x, x equals sine y. The derivative of x is simply 1. The derivative of sine y would be cosine y dy over dx. Well, our next step's to separate, but they're already separated. Dy dx is by itself, the things without are on the other side. And we don't need to factor because there's only one of them, so the only thing to do is divide. So we divide both sides by cosine y, and we get dy over dx equals 1 over cosine y. You can leave it like that, or if you remember, that's also equal to secant y. Either way will work. 13. If 2x squared minus 3y squared plus 4x minus 3y minus 6 equals 0, what is dy dx at the point 1, 0? So we need to take the derivative with respect to x. Gives us 4x minus 6y dy over dx plus 4. The derivative of 3y is 3 dy over dx. And the derivative of 6 is 0, so we just don't worry about it. Now I need to separate all the things with dy dx from the ones that don't. I'm going to move both the things with dy dx over to the right side and get 4x plus 4 equals 6y dy dx minus 3 dy dx. That's my step 2, separating the dy dx's from things that don't have it. Then I need to factor out the dy dx. Divide both sides by 6y minus 3. So I have 4x plus 4 over 6y minus 3 equals dy dx. Now if you notice, it didn't simply ask for dy dx. It asked for dy dx at the point 1, 0. So now we have to plug in 1 for x and 0 for y. Giving us 4 plus 4 over 0 minus 3, or negative 8/3. Actually, one correction to that. I'm looking back up my work here and seeing when this is added over, it should have been a plus. So let's change those to pluses, which would make this a plus 3 on the bottom, so a positive 8/3. Sorry for that mistake. Alright, now we're starting with the related rates. The volume of a cube is changing at a rate of 12 cubic meters per second. As soon as I see even this unit, I know I'm dealing with dV dt. I know that because we're dealing with cubic, so that's volume, and per second, so that's a rate. So I'm going to go ahead and write that down. The dV over dt is equal to 12. When each edge is 4 centimeters, so my sides or my edges are 4, how fast are the edges or the sides expanding? So what is ds over dt? Now we're dealing with a volume of a cube. That volume is v equals s cubed. The derivative will be dv over dt, that's the derivative of v, and then 3s squared ds over dt. So dv over dt is 12, s is 4, and then we try to solve for ds over dt. 4 squared is 16 times 3 is 48. So then we divide both sides by 48, and you should get 1/4 for your ds over dt. 15. A machine is rolling a metal cylinder under pressure. The radius is decreasing at a rate of 0.1 inches per second. So that's the radius's rate, so that's dr over dt. It also says it's decreasing, so I need to do negative 0.1. Volume is equal to 256 pi. At what rate is h changing, meaning we're looking for dh over dt, that's our goal, when r is equal to 3.6. Okay, so we need to use the volume equation pi r squared h, and we need to take the derivative of that. And to do that, it's going to require the product rule. Let me quickly do that for you. F will be pi r squared, g will be h, f prime is 2 pi r dr over dt, g prime is dh over dt. So our derivative is going to be 2 pi r h dr over dt plus pi r squared dh over dt. Now if within each term you put something in a little different order than me, that's fine. Remember, you can multiply things in any order you want. So let's start plugging in what they gave us. I know my radius is 3.6. I don't know my height at the moment, so we'll come back to that. I know my dr dt is negative 0.1. I know my r is 3.6. And I'm trying to find dh dt. So I'm actually missing two pieces, dv dt and dr dt. Let's talk about dv dt first. It says a machine is rolling a metal cylinder under pressure. So here's what you have to picture. You've got something that's a solid metal cylinder, maybe the shape of a Coke can, for example. So it's not a Coke can because it's solid, but it's about that shape. And what happens is it rolls it out and puts pressure on it till it becomes longer and skinnier, more like a long metal rod instead of a short, thick cylinder. So think about the way you used to take Play-Doh when you were a kid, and you would roll it on your desk until it became a long, skinny snake. So it started as something big and thick, and then it became long and thin. Well, think about that carefully for a minute. How does the volume of the Play-Doh, or in this case the metal, actually change? It doesn't. We're not changing how much metal there is, we're just changing the shape of the metal. And if the volume is not changing, that tells us that dV over dt is 0. Now, to find, I think I said we need dr dt, excuse me, we need h. H was the other thing missing, because we have dr dt, it's right there. So now let's look at how we can find h. Well, the only place I see h is in the original equation. See it right here. Well, luckily, they gave me the volume, which I can plug in right here, and they gave me the radius, which I can plug in right here, and I can use that to solve for my height. So let's do that. I'm going to have 256 pi plugged in for volume, pi times the radius, which is 3.6 squared, times the height. So I divide both sides by pi, and that goes away. Then I do 256 divided by 3.6 squared, giving me about 19.753 for my height. So that's what I'll plug in for my height. 19.753. Sorry, it's hard to read. The height is 19.753. Alright, so now we have all our pieces we need to solve for dH over dt. So I'm going to multiply that whole first term together. 2 times pi times 3.6 times 19.753 times negative 0.1. It gives me negative 44.680 plus pi times 3.6 squared gives me 40.715. So now I'm going to add this over and get 44.680 plus 40.715. And then divide both sides. Alright, this is equals, my fault. Then we divide both sides by 40.715. And that gives us 1.097. So the rate at which our height is changing is 1.097. Alright, this is actually going a good while, and we've got two more, so I'm going to put the last two on the final video. Just a couple hints here again. The amount of metal was not changing, so that's why we said dV over dt is 0, because the volume of the metal we have isn't changing. And also we had to use the radius and the volume back in the original equation to solve for our height.